Hi, this is Dr. Flippin. This is week one of CMD 375 Communication Development. Thank you for still being enrolled. Hi, let's get started on week one. So, I want to talk to you about differences between communication and language and speech. And sometimes when we talk about them, they all get lumped together, but it's important to differentiate one from another so later on you're able to know what your client is struggling with and how best to treat it. So at the bottom of the pyramid, you'll notice this is a hierarchical structure. They are not all the same thing, and one falls within another and then within another. So let's go through each one. At the bottom of the pyramid, you'll notice is communication. In the middle is language, and at the top is speech. Communication, very broadly, means the exchange or imparting of information or news. It's all the ways we interact with other people. And the other people part of this is what's most important. Right? So I want you to think about ways that you communicate with other people and ways you may use speech and language without communicating. And we'll talk about this together on our forum. But I just want you to start thinking about, okay, how do I use one of these but not the other? That's communication, the exchanging or imparting of information or news. Language is the symbol set we use in order to communicate. And there are hundreds of different languages, including English and all of the spoken languages, but also ASL and computer language. So language is a symbol set we use to communicate. And finally, the third one, speech. Speech is even more specific, right? It's at the top of the pyramid. Speech is the mechanical process of language, such as articulation and phonation. Speech, very simply, is movement made audible, right? So you're moving your tongue, lips, vocal folds, diaphragm in order to produce sound, and that's speech. So communication, language, and speech are very different from each other. And so we'll go back and recycle to this on the forum and talk about ways that they are unique and similar. Okay, so let's talk about language now. So we're in the middle of the triangle. Every human culture has a language, right? And it's kind of amazing the way language is acquired in typical development. So by about age 6, kids understand almost 13,000 words. So, in 6 years of life, they've developed a vocabulary of, a receptive vocabulary of over 13,000 words. Amazing, right? By 18, which may be where some of you are, you understand 60,000 words. Isn't that amazing? I have 6-year-old twins, and they're in a dual language immersion program, which we might get to talk about over the course of this semester. And when they first started, they're Byron and Nora. Byron was telling me, I think I might want to do the Spanish because I already know the English. Does Byron know all the English at age 6? No, right? He, between 6 and 18, he will acquire hopefully another 50,000 words if everything stays on track in English. And then hopefully he'll stick with the Spanish and he'll also have the Spanish vocabulary. I'll keep you posted. Babies discriminate sounds that their parents cannot. So we are born with the capacity to learn all languages, right? For example, babies born in Japan are able to discriminate the sounds R and L, although that difference is not made in the Japanese language. So as you grow, as children grow, your brains become, pruned or wired specifically for the language that you're exposed to, which is why, we try to intervene with children experiencing language delays as early as possible, ideally before 5, right? And when you want to learn a new language, it's very difficult to become, you can do it with exposure, but it's difficult to become a native fluent speaker if you haven't had exposure before age 5. As the twins tell me, they'll come home and they'll say, Nora, tell me some of the words you're learning today, and they'll tell me, Mom, you're you're too old to learn the Spanish, you can't lay down the tracks. So, yeah, so I gave them fewer birthday gifts. No, I'm teasing, but in some ways they're right, right? Um, yeah, okay. So, you are born with the capacity to discriminate all sounds, even if they don't exist in your language. And as the neural pruning happens, as you develop these pathways specific to your language, that ability to discriminate drops off as early as 10 months, right? Your brain is becoming very specialized for the environment it's in. So what makes it possible for you to use language? What makes this possible for humans? Um, do animals have language? Well, no, they don't, right? So language has evolved over time, and we can see, earlier forms of, beginning communication in animals. But, bees can dance in stereotype ways, and you'll read this in your text. Other animals can mimic human speech, right? When we think about parrots, they can mimic speech. Simians might learn gesture and object associations, right? So we're getting closer to language use. But only humans can spontaneously learn and create languages. And language is uniquely human, which is kind of amazing. What makes this possible? Our brains are set up to use language. We are, exquisitely wired for language use. What makes this possible? So if you look here I want to point out Broca's area in the purple and Wernicke's area in the green. And so this is a very simplistic kind of diagram for you, but it's an easy starting point. We now know that other areas of the brain are involved in understanding and producing language, but this is a good starting point. So if you look at Broca's area, let's talk about that first. Oh, hold on a second. Pause this. Really pause it. I want you to pause this and draw, for me, a left hemisphere with Broca's area, the motor cortex, the sensory cortex, and Wernicke's area. See if you can do it. Test yourself. This might be on a quiz. There is nothing like drawing it to realize what you understand and you don't. Take a minute and do this, and then press go and we'll catch up. Okay, how'd you do? Did it look like this? Okay, you wanted to draw Broca's area, the motor cortex, the sensory cortex, and Wernicke's area. Check yourself. You're going to need that again later in the course. Okay, let's talk about aphasia. This is sort of the most fun way to understand how these language areas work in the brain. Here's Pierre-Paul Broca, and he was studying a patient, Tan. And he found that, Tan had a brain injury. It turned out to be an abscess in his left frontal lobe, which we now call Broca's area after Pierre-Paul Broca. So Broca's patient could answer questions with gestures, right? He could nod, and he could shake off. He could say a few curse words. Those are really, resilient. We all need those. They're very motivating. And Broca wanted to disprove cortical speciality. So, he performed an autopsy on his patient's brain, and what he found was, the area of infarct was localized exactly to his left frontal lobe, and we call that Broca's area, and that's here. So you can see the infarct here on the left frontal lobe, and that's Broca's area. And when we have a stroke, CVA, when you have an infarct to that area, this is what happens. So here's an example. Your patients end up with their language comprehension pretty good, right? They can understand what you're saying, right? But their production's impaired, right? So they may be non-fluent, right? Their words may be improperly formed, slow and slurred, right? And they may make paraphasic errors like turnpike for turnpike. When you go into your patient and, right after the insult, if you go in and part of what we do is find out how much language is left and what's impacted and how. And, they may be able to give you some cues as to what they're trying to label, but may have trouble word finding issues finding the word. So, for example, you can present them with a spoon and they may not be able to produce the label for spoon, but they can talk around it and come up with something like a dig food thing. They know what you're saying, their production's good, they cannot produce or find the words. So here's an example. If you ask your patient, were you in the Coast Guard? Your patient may respond something like, no, yes, yes, ship, Massachusetts, Coast Guard, years, right? And hold up their hands to gesture a number. So very slow, halted, possibly slurred speech, non-fluent, but production intact. Okay, so that's one kind of aphasia, sorry. So now if you think about the other part of the brain, so Broca's was left frontal lobe, and now we move to the back to Wernicke's area, which is here. And you can see it's behind the sensory cortex. So when you have an insult in Wernicke's area, it's much different. So for folks with a Wernicke's aphasia, their language comprehension is poor. They do not understand what you're saying, right? Their speech may be fluent, but nonsensical, right? So they're able to produce, and they're able to get a lot of words out. It just doesn't mean anything. And they can produce long sentences with no meaning. So, for example, if you were to approach a Wernicke's patient in the hospital and ask, what brings you to the hospital? They may respond, so it's much different than a Broca's patient who is struggling to get their words out. This is no problem for clients with Wernicke's aphasia. They may answer, boy, I'm sweating, I'm awful nervous, once in a while I get caught up, I can't mention it. The Terry Poet, a month ago, quite a little, I've done a lot, I impose a lot, while on the other hand, you know what I mean, I have to run around, look it over, Trebin and all that kind of stuff, right? Wernicke's, when the impact is in Wernicke's area, it presents in a very different way than when it's in Broca's area. And these are your first cues as to where the insult is in the brain. So when we think about these two areas of the brain, there's also two sides of the brain, the left and right hemisphere, right? Speech is supported by the entire motor system. It takes the entire motor system to make movement audible, right? If you are right-handed, your language is subserved by the left hemisphere for 98% of right-handed males and 90 to 95% of right-handed females. If you are a lefty, your language is subserved equally by the left, right, or both hemispheres. Isn't that neat? Okay. So, what is awesome about humans, among other things, is that between Broca's area and Wernicke's area of the brain is the arcuate fasciculus, right? And this is a white matter tract that connects Broca's and Wernicke's area. So if there's damage here, what you find is conduction aphasia, where your client's comprehension is intact and they have fluent speech with some paraphrasic errors, right? But they are unable to repeat words, right? The connection between comprehension and production is damaged, right? So I want you to take a look at the areas in lime green. So this, when you look at the macaw and the chimpanzee, you do not see this nice clear connection between Broca's and Wernicke's areas. When this evolved for humans, we developed the capacity to use language because we were now connecting our production areas with our comprehension areas. So the arcuate fasciculus plays an important role in making language use possible for humans. Thank you.